on everybody. So today let's going to do leetcode number 56, merge intervals, which is about arrays question. So let's dive in. Always, let's try to understand the question first. So given the array of intervals where intervals I is equal to start and end, so basically it's an array of pairs. So merge all overlapping intervals and return an array of the non-overlapping interval that cover all the intervals in the input. So it's always, to even during the interview, it's good to do the analysis on some of the example input, and you ask the interviewer, is this the expected output? So let's try to do that. So given the intervals 1, 3, 2, 6, 8, 10, 15, 18, so the output is, since we see that these two intervals has an overlap, so we take the starting point here and the ending point here, and we will do a more detailed analysis later. So we merge these two together, and the next step is probably going to be like you compare the merged version of this two interval compare with the next element in the array, and on and on and on. So in this case, there is no overlap between this two the merged version of this two and this one. So we just push this to our output. So finally, the expected output is going to be 1, 6, 8, 10, 15, 18. Okay, so basically, what we trying to do is to merge all possible overlapping. And the first thing comes to my mind is using the divide and conquer, but actually it's a bit overkill because I was been misled by the merge sort or something. But sorting is also a pretty important technique for this question. So let's try to dive in the explanation part to look into the details. Now let's do our explanation part. And so let's think about what's the first thing we need to do. The first thing we need to do is detect all those overlap, right? So how can we, when will the overlap actually happen? So let's go back to the previous examples. So we got like 1, 3, 2, 6, 8, 10, and 15, 18. So one thing you guys probably do aware of is that the starting point of this pairs has been sorted. Why we need to do that? Because in this case, it makes sure that, okay, the starting of this interval do happens between the next element in the array. So in that case, what we really want to compare is what about the ending point of this intervals with the next element, right? So if this thing is greater than the starting point of the next element, which means that the overlap do happen. And let's do a So that's the reason why we need to sort the starting point of each pairs. And so let's just say the first step for this question is to sorting the array based on the starting time of each pair. Okay, so this is the first thing we need to do. Okay, so what's the next thing we need to do? It's actually, we have already mentioned that it's like you have to compare the ending point of the first pair against the starting point of the next pair, right? So let's just try to check out one examples. Let's do 1, 3. Let's just do what the question given to us, 2, 6, and 8, 10. Okay, let's do the analysis on this question. And actually, a good practice is just visualize it. So 1, 3 is here, and 2, 6 is probably like 6 here, and 8, 10, and here's probably 8. I don't like that period. 10. Okay, so here's the first interval, the second intervals, and the third intervals. And we can clearly see that this is what I mentioned before. If we sort a starting point, which can help us detect where the overlap is. So in this case, so the ending point of the first intervals is after the starting point of the second intervals. So here is where the overlap occur. And let's back to this example. It's like the ending point of this intervals is actually before the starting point of the next intervals. So in this case, there is no overlap. So one more thing we need to keep track of is like what's our output is. So we probably need some of a list, and we say it's merged. Let's say it's merged. Okay, so what should we put inside of this list? So for example, initially it's probably just the first pair, because it can be. So initially it's probably just our first pair of all the intervals. And now it's actually where the magic happened, is that we should compare the last thing in our merge list with our next element in our arrays. Why? Basically, we also mentioned that what do you actually want to compare is not 2, 6 and 8, 10. It's actually what we want to trying to compare is the merged version of all the previous intervals, which is like the last element in our merge list, to with this our next element. So let's just trying to populate this list and go through with these examples. So initially it's 1, 3, and then we do the merge with the next element. We do 1, 3 merge with 2, 6, which is actually 1, 6, right? Okay, so we update the merge list, and now again we do the same thing. We're trying to compare 1, 6 with 8, 10. Okay, so we know that there's actually no overlap in this case. So we just push that new intervals to our array. So finally, the merge list will look something like this. To make a conclusion here, what we actually trying to do is to compare the last pair in our merge list to the next element in the interval arrays. So we can denote them as like the first pair is S1, E1, which is corresponding to starting point 1, ending to point 1. And the next pair we can call it as 2, E2. Okay, so now we can do a case analysis, like how's the merging process be like. So the first case is fairly easy. It's like, what if they don't have any overlap, right? So to visualize it, it's actually looks something like S1 is here. Here is ending point of the first intervals, and the second interval is actually starting at here. And E2. Okay, so in this case, these two intervals has no overlap. So what's gonna be looks like in our algorithm? As we mentioned, since this is end of the previous probable overlapping period, so we just need to push the S2, E2 to our merge list. Okay, so this is our first case, and the second case is case number 2. We have the overlap. So for this cases, there's actually 2 sub cases. Let's try to see. So S1E1 is here, and to have the overlap, S2 should start something right here, right? It should be between these two, between these intervals. And the interesting thing is, okay, let's just put it right here. The interesting thing is, where's the ending point of these intervals? It probably ended right here, right after, right? So in this case, we can push E1 here a little bit. So here's the first scenario, is like this whole thing included the second intervals. So that is the first cases. But there's another possible cases. It's like E2 is stop something right here. So in this case, the whole overlapping intervals is going to be S1, E2 prime prime. And for the first case, the whole intervals is actually S1 and E1. So how can we conclude this? And the starting point is certain, as we said, because we do the sorting first. So S1 is definitely be greater than S2. So how can we decide the ending point, right? So starting point is fixed. How can we decide the ending point? So as you can probably see, we either take E1 or E2, but what we actually trying to take is the maximum between these two numbers. So we just take max between E1 and E2. And finally, we just update this overlap to the merge list. Why I use the word updated? Because you probably have S1, E1 initially at the merge list, and now you actually trying to push this new merged version of interval back to the list. So you probably have to delete this first and push into this one. Okay, so here's all about the explanation for the algorithm. So let's now translate all of our thought into Java code. Dive into the coding part for this problem. So as always, I would like to put up some of the constant. So the count is actually count the number of pairs in our intervals array. So we can do intervals dot length. Okay, so based on our planning step, the first part we need to sort the array based on the the starting point. So we can use the Java's array sort, and we can be passing intervals, and we actually have to customize our comparator. So we taking a pair. So what we actually trying to compare is like the first element of this pair, and each pair is like an array. So integer dot compare, and what we're trying to compare is A0 and B0. Okay, nice. So we finished the sorting part, and then what's the second step is to set up our merge list. Okay, so as you can see that we push it to the end of the list, and we kind of also trying to edit the end of the list. So in this case, it's more flexible to use a linked list. So what's the element for this linked list? It's actually each pair, right? So we just can passing an integer array as our type, and we call it merged is equal to new linked list. Okay, nice. So the first thing we need to put into this list is actually the first intervals, right? So in that case, we treat the first intervals at the end of the linked list. So just merged dot add, and we're trying to pushing the first element since it's sorted, so we can just do this directly. Okay, now we kind of finish all the setup, and after that we just iterate through the rest of the intervals and do the merging, right? Okay, let's set up a for loop for that. In I, we're starting from 1 because remember we have already pushed the first element into our linked list. So we do I is smaller than count. Count is the constant that we put it out, and we do I plus plus. Okay, so again, let's try to put out all the things we need to use. The first thing we need to put out is the end of the merge list, right? Okay, we can call it pair 1 is equal to merged dot peak last, because we need to get the end of the list. Okay, so here I want to bring it up. A quick knowledge point is like, what's the difference between the peak and the pole? Okay, so for the peak is that we retrieve the value without remove it, and for the pole we retrieve and we remove the value as well. Yeah, it's good to remember. Okay, let's keep doing our code. So the second pair is actually the next element in the array, right? So we can just do intervals dot I. Okay, nice. Now we get to intervals that we're trying to merge. So remember, we have two cases. The first case is we don't know overlap. So when this case will happen is if our pair 1, the ending point of the first pair is smaller than the starting point of the second pair, right? 0. So in this case, we know there's no overlap. So what we do is we just push the second pair and we do it at last, we just push the second pair to our linked list. Something like this. Okay, else is actually the case we do have the overlap. Okay, so when we do have the overlap, what we need to do, we need to find our new intervals, right? So basically the merge version. So we can do like int new pair, which equal to remember the starting point is fixed, is the first element of the first pair, and the second pair is actually the max between the ending point, right? So we can do a max, and we taking pair 1 the ending point of that, and pair 2 the ending point of that. Okay, so now we create a new pair, and do remember, before we push to the list, we have to remove the last element of the in the merge list. So basically this is like the whole update process, and then we can push this new pair to our linked list. Okay, it's new pair to our linked list. Okay, so finally, after we go through all the thing, we were populated our merge list. So it's going outside the for loop. So at the end, we just want to return this array version of the linked list, because you see, our actually trying to do is a 2D array. So we convert the linked list back to array, and let's do the trick. It's the merge.size, because we want to have the same size as our linked list, something like this. Okay, now we finish all the coding part, and let's try to run the code. Okay, do pass the task cases, and we submit it. Okay, it runs pretty efficiently. Let's try to do a runtime and space analysis. So what I like to do is just go through the code. Let's see what we actually doing, right? So this build up a product constant, take constant time, which is 1. So sorting, the kind of the usual efficient sorting algorithm take n log n. So this takes n log n, and all this setup take the constant time, and this iteration will run big n times, right? So let's see what it do inside. We just trying to do the comparison and push to the list. So all these things will actually take constant time. So the for loop as a whole will take big O of n. So in general, the overall runtime is going to be n log n, which is dominated by this sorting algorithm. So we can just say it's n log n. So let's go to our space analysis. So what we trying to do is we build up this merge list, right? So in the worst case, it's all the elements don't have the overlap. So we have to push all the intervals to the merge list. So in the worst case, the space complexity is big O of n. Okay, so that's all for this videos. Hopefully you will like it. Don't forget to subscribe and comment down below. Appreciate it. See you guys next week.